All right, in this video, I'm going to go through the basics of graphing a rational function. To get full credit on the test, you're going to need to be able to factor correctly so you can see what cancels out. You need to find all intercepts, any holes, and any asymptotes. And you need to be able to draw the overall shape of the graph. It doesn't need to be 100% accurate, but all of the important features need to be there, and the arms and such need to be traveling in the right direction. The three cases that you'll need to know for finding the long run behavior are when the degrees are the same, and then you just take the ratio of the leading terms. So this would have a horizontal asymptote at 3/5. When it is bottom heavy, then the horizontal asymptote is automatically y equals 0. And when it's top heavy, you're going to get a slant asymptote. We'll do an example later in the video of that, but you would use long division, and that would tell you what it would be. There would be no horizontal asymptote in that case. Okay, so I'm going to run through three graphs here, showing you the process to help you remember what you'll need to do. So the first one, we will start by factoring. Use AC method or whatever you would need to do. And let's see, it's going to be -4 plus 3. Okay, so we want to see if anything's going to cancel out, and sure enough, it does. There will not always be something that cancels, but a lot of times that will happen. Because it canceled, we get a hole at -3. And to find the y-coordinate, we're just going to plug it back into our simplified form and get a result. So that's going to be -5 over -7, better known as 5/7. All right, we can go ahead, we can graph that if we want right away. So -3 5/7 would be about here. The x-intercepts, right, we would set the whole fraction equal to 0, right, let y equal 0, but that can only happen when the numerator is 0. So a little shortcut would just be to set the top equal to 0, and we can see we would get that. To find your y-intercept, you let x equal 0 and simplify. And you can do that with the simplified thing or the original thing. It doesn't matter. Either way, you get -1/4. Your vertical asymptotes, after you have canceled everything, you want to see if anything remains in the bottom, because anything in the bottom could cause division by 0. And in this case, that would be 4. And your horizontal asymptote, again, we look at our three cases. This would be an example of same degree. So looking back at the original or your canceled form, doesn't matter. You can see you're going to get 2/1. Right, so we'll make our graph. So let's go ahead and plot our intercepts. -1/2 goes right here, and -1/4. Just do the best you can. Roughly where they go is fine. Add your asymptotes. And if you add all those basic features, we'll give you a point. And now you want to think about the graph. So these look like they're going to connect. And then as graphs go toward infinity, they want to approach the horizontal asymptote. And as they go toward vertical asymptotes, they want to either go all the way up to infinity or all the way down to -infinity. So this one's going to continue on down. The question is, what about on the other side of the asymptote? And there's a couple ways you can do that. The first, and this is probably the easiest thing, is to know how asymptotes work. So what caused this asymptote in the first place was this x minus 4. If that factor only appears once in the denominator, so in other words, the exponent is 1, then the other side of the asymptote will have the opposite behavior, i.e. if one side is going down, then the other side is going up, or vice versa. If, not that this happens in this example, but if this were squared, then it would have the same behavior on both sides. Okay, so if it's an even asymptote, then the arms do the same thing. If it's an odd asymptote, like this one, then the arms do the opposite thing. The other thing you could do is you could plug in points to try to determine what's going on. So you could plug in, say, like 5 would work, right? Something to the right of the asymptote. And you can plug it in your simplified thing, and that would give you 11/1. So you know when you plug in 5, you get 11, which goes off our graph a bit, that tells you most likely it's going to look like this. Okay, this is good enough, this is accurate enough, you don't need to be any more detailed than that to get full credit. Okay, another example. This one, again, we would begin by factoring. Okay, and you factor it all the way out. You would see that there's a difference of perfect squares in the bottom. You'd take out the GCF. Okay, that you should all be able to do by now. And we notice that the 3 is going to cancel. So we get a hole at -3, whatever makes it equal to 0. And plugging that back in, we get -1/18. Okay, our x-intercepts are going to be -2, 0. And our y-intercept is, well, there's not going to be one because, again, how do we find a y-intercept? We let x equal 0. But when you do that, there's a 0 in the bottom, right? And so that is undefined, right? Can't divide by 0. So we're just going to say there is no y-intercept. That can happen. Okay, there could also be no x-intercepts or no hole or no asymptote, right? That can also happen. All right, vertical asymptote, there are 2 of them. All right, 0 and 3 in this case would make you divide by 0. And the horizontal asymptote, this is bottom heavy, so we're going to say y equals 0. All right, we go ahead and plot all that. 0 and x equals 0 as well. And x equals 3. Okay, and now we graph our intercept. So notice this is on the horizontal asymptote. That's okay. You can touch a horizontal asymptote. You cannot touch a vertical asymptote because that's caused by division by 0. But a horizontal asymptote just tells you what's happening as you go out towards the ends of the graph. It doesn't tell you about the middle at all. -3, -1/18 would be down here. Vertical asymptotes, okay, that's all good. And that's all the information we have. So, you know, this is again where you could plug in a point, or, you know, if you're not sure, like let's plug in -1, that would be easy enough. And again, use your simplified thing when you do that. And that's going to give me 1 over, let's see, +4. And so I know that's going to be like here. And so that's enough to tell me, you know, this is going to go up, and it's probably just going to approach that asymptote. And then what'll happen is as it goes out forever, it's going to want to get close to the asymptote, like so. Okay, so then on the other side, you could plug in 1 if you wanted, but again, I know if this is going up, this is going to be coming like this. Because, again, this thing that caused the asymptote, right, x is to the first power. And then, okay, I'm not sure what's going on with this asymptote. So another little trick that you can do is you can plug in something really close to the asymptote. So the asymptote's at 3. So let's plug in 2.9. I'll show you. Now you won't have a calculator, but that's okay. Because all we really care about is the sign of the number. In other words, is it positive or negative? So looking at the top, that's obviously a positive number. And looking at the bottom, that would be negative, that'd be positive, that'd be a negative. And so a positive divided by a negative is negative. Okay, now we could do the arithmetic if we wanted to and actually get the number, but we don't need to. What we just found out is when I let x equal 2.9, I get a negative number, which tells me that this arrow is going to want to probably go this way. And so that tells me this is going to turn around somewhere. Another sort of intuitive way I could know that is there are no other x-intercepts on this graph. This is the only place it can go across the x-axis, so the graph couldn't look like this because you'd get another x-intercept. So intuitively, it sort of has to turn around somewhere. Now, we don't know exactly where, and we don't really care exactly where. This would get full credit, and so would this. What we're really looking for is, do the arrows go the right way? And on the opposite side, you're going to get the opposite behavior. Right? This one is going down, so this one's going up. But you could plug in points to confirm if you wanted. One final example would be one that is top-heavy. So these are a little different because you need to do long division. But we'll start by doing the factoring like we always do, because you never know if something's going to cancel out. But in this case, nothing does. Our x-intercepts would be -2 and 0, and -3, 0. Our y-intercept would be, let's see, 3/2. Our whole, there isn't one, right? Nothing canceled out. Our vertical asymptote's at -4, and there's no horizontal asymptote this time. We're going to use a slant asymptote, and so I'm going to do the long division. Okay, so setting that up, x squared plus 5x plus 6, and we divide. X goes into x squared x times, and we multiply through, right? Distribute it, and then change the signs, right? Subtract, and that goes away. That leaves me with x. Bring down the 6. X goes into x one time, and I can actually stop right there. It doesn't matter what I get down here, because I'm going to get some remainder that I don't care about. And so I can just ignore that, and I'm good. As long as I get a linear equation, I can stop. You just throw away the remainder. And so we know it's going to be y equals x plus 1. Okay, we go to our graph. Let's put our intercepts, -2, -3. Let's put our y-intercept of 3/2. Let's put our vertical asymptote of -4. And finally our slant asymptote of x plus 1. Now this just, it is a linear equation, so you do need to be somewhat accurate here. It starts at 1 and has a slope of 1. Let's see, graph it just like you did all the way back in Algebra 1. Good old y equals mx plus b. Okay, and so what's going to happen here is these points, right, it's going to dip below, come back up, hit this point, and as it goes toward infinity, it's going to want to approach the slant asymptote. And over here, it's going to want to shoot to infinity. And then on the other side, right, again, this is to the first power, so odd behavior. It's going to come from the bottom, and then it's going to want to turn around and go along the asymptote like so. Right. All of the examples on the test are very much like these. If you can graph these, then you know what you're doing. However, you can try the practice packet that we've given you. If you have any questions, send us an email. Otherwise, have a great day.